Hi everyone, welcome to my channel, Tutorlini Test Prep. Today we'll be going over Ottocento number 28, Literal Equations. The goal of the Ottocento course is to teach students everything they need to know about the digital SAT math exam. Please see the link in the description to download this video's worksheet for free. Let's get started. Okay guys, so the first thing we need to talk about is negating a difference. So this is going to be very important for questions like this on the SAT, but it's also going to help you in later classes when you take like your pre-calculus and calculus class. So let's say we wanted to distribute this negative sign to the quantity a minus b. That would become negative a plus b. We could then use the commutative property of addition to rewrite it as b plus negative a, and a positive times a negative is just a negative. So we could rewrite this as b minus a. The reason I'm going through this with you is because you want to be able to do that in just one step. You don't want to do 3 or 4 steps just to go through all that. For whatever reason, when we simplify, and this holds true for most of the time on the SAT as well, when we simplify, we don't want to have a leading negative. Think it's way better to say 5 minus 3 than negative 3 plus 5. So for example, if we had negative the quantity 3x minus 4y, we would just swap the order in one step. You don't need to do all that work. So that would be equivalent to 4y minus 3x. So to negate a difference, just switch the order. Next, this is really not that important, but I feel like it's helpful most of the time. Within a term, you want to alphabetize the variables. So do not write 5y cubed z x squared. And instead, you should probably write 5x squared y cubed z. They're both the same term, but notice how I just, on the left, put them in alphabetical order. It's not super important, but that's probably a good habit. Okay, this is our first example. You'll notice almost all these questions have this very important key phrase, in terms of. This phrase, in terms of, whatever comes before this, in this case y, is the variable we want to get by itself. So to make this more clear for the rest of the video, I am going to be coloring the desired variable in blue. So hopefully that will make it easier for your eyes to follow along while you're learning what's near the blue variable and what needs to get moved. So a great way to think about algebra operations, it doesn't always work, but it works pretty well. If you think about PEMDAS, and then you just think about algebra operations as PEMDAS in reverse. So you see on the same side as this blue y, I have a 2 and I have a 3b. The 2 is being multiplied and the 3b is being added. Well, if you look at that chart and read it backwards from the bottom to top, addition subtraction comes first. So we're actually going to take care of the 3b first. So the 3b is being added. The opposite of addition is subtraction. So we're going to subtract 3b from both sides. 3b minus 3b is 0. And we are now left with 2y equals x minus 3b. And now all we have is a 2. We don't really need to look at the chart. It's the only thing we have to move. It is being multiplied. The default operation is multiplication. The opposite of multiplication is division. So we're going to divide both sides by 2. 2 divided by 2 is 1, which is an implied coefficient. We don't write that, so it kind of goes away. And we get y equals x minus 3b all over 2. And that would be the answer for this question, probably in the answer choices. So I'm only going to be putting multiple choices on the worksheet just to make this video go faster. So hopefully that's okay. Try not to let that confuse you. Try to just, while you're in the lecture portion of the video, try to focus on what algebra operations you need to do and worry less about the final answer itself. You can worry about that when you get to the worksheet. You do have to try to make it look like what's in the choices. We will talk about that. Okay, one last thing before we get into the meat and potatoes. Splitting and combining fractions. I imagine a lot of people watching this don't really know what that is. So you might want to go watch a video on it. I picked one out from YouTube that I thought was good. Basically, the main takeaway is You only really want to be splitting fractions when there's one term in the denominator. So notice how in this example that I provided, one term is in the denominator. So maybe splitting fractions could work out pretty well. It kind of depends on what's in front of you in the answer choices, whether you would put the thing on the left or the thing on the right as the answer. Okay, so for this one, I see that key phrase in terms of, and the letter that comes before it is K, so that is the letter we want to get by itself. We want to get K by itself. That is our mission. So whenever I have two fractions equal to each other, probably a great thing to do is to cross multiply. We just multiply the diagonal, so I'm going to multiply these two together and set it equal to the product of these two. And I get 35K is equal to 24JL. And now I'm just looking where the blue variable is. The only thing that's near him is at 35. It's getting multiplied, so the opposite of multiplication is division. We're going to divide both sides by 35. This 35 on the left here goes away. And we are left with K equals 24JL over 35. And that would perhaps be the answer. Now keep in mind that 24 over 35 cannot be simplified. If this fraction could be simplified further, you'd probably have to do that. We just got lucky here. Okay, once again, I see this phrase in terms of, and the letter that comes before it is U. So our strategy is we're going to try to get U by itself. So let's do that on the next slide. Let's make U, let's color him blue so that he's easier to see. And again, thinking of like reverse PEMDAS, the 8 minus U are a group. They are inside a parentheses. So if you're like going from the bottom up, we tackle those last. So we're going to want to tackle that T first. So the T is being multiplied to the parentheses. So we're going to do the opposite of multiplication, which is division. So we'll divide both sides by T. These T's on the right will kind of go away. And that will leave us with S over T equals 8 minus U. And now I'm just looking on the side with the blue in it. And I see that there's an 8 over there. The 8, don't get confused, guys. The U is negative, but the 8 is actually positive. So to get rid of that 8, we're going to not add, we're going to subtract 8 from both sides. Subtraction is the opposite of addition. So if I do 8 minus 8, sure enough, I get 0. So he goes away. And we are left with S over T minus 8 equals negative U. Don't forget to put that negative sign. Lots of people probably would have forgot that and got it wrong. Okay, now to get rid of that negative sign, we're going to multiply or divide both sides by negative 1. Why don't we just multiply both sides by negative 1? And negative U times negative 1 just becomes positive U. And that thing on the left is actually a difference. We went over that earlier in the video. Just swap the order of the difference. So we get 8 minus S over T is equal to U. So that could totally be the answer. However, perhaps sometimes on the SAT, they will have you combine the fraction. So what I'm going to do is I'm going to try to get then an LCD of T, because the denominator is T on the right side. And to do that, I'm going to multiply the 8 by T over T. Notice how we don't need to do that to both sides because T divided by T is just 1, and 8 times 1 is just 8. So we're not changing the value of the right side at all. It's staying the same. So we don't need to do it to the left side. And this gives us 8T over T. Everything else stays the same. And now that they have a common denominator, we can combine them just like that video I pointed out goes over. And we get 8T minus S over T. And it kind of depends on what choices have in front of you, but either one of these is probably how the College Board would write it in the answer choices. Okay, example 4. Once again, we see this key phrase in terms of. Notice how something different with this one. The thing they want us to isolate isn't a variable, it's an expression. So we're going to get that big expression by itself. Hopefully you can see there's already very clearly a 3b minus 8 in the equation. Just kind of with your mind's eye, pretend that there's like a big variable, and we're going to try to isolate that. That's what I would do. Okay, so I now have 3b minus 8 in blue because that's what we're trying to isolate. Fraction bar is a group, so we're going to tackle the fraction bar last. So that just leaves us with the 5. So why don't we subtract 5 from both sides? Also, guys, we'll talk about this later. Clearing denominators can be very helpful, but when you just have one fraction, it's not really that helpful. So why don't we take away 5 from both sides? That guy goes away. And we're left with y minus 5 is equal to d over 3b minus 8. Now, at this point, when the thing we want to isolate is in the denominator, it's probably a good idea to get him out of the denominator because we don't want him there. So why don't we multiply both sides by 3b minus 8? Then these guys will go away, and on the right will go away, and we will be left with 3b minus 8 times y minus 5 equals d. Now we're in the home stretch. The only thing with the 3b minus 8 is the y minus 5. It is being multiplied. So we're going to divide both sides by y minus 5. These y minus 5s go away. And we get 3b minus 8 is equal to d over y minus 5. And that would probably be the answer. Okay, once again, we see this key phrase in terms of, and the letter that comes before it is y. So our strategy is to get y by itself. So now notice, guys, there's something very different about this equation. The desired variable is in more than one location. So there's something very specific that we're going to do to tackle that. And what we're going to do is we're going to get all the terms with the desired variable, in this case y, to one side, and then we're going to get the terms that don't have the desired variable and put them on the other side. So for me personally, I'm looking at this, I'd really like to get the y's on the left side, and then the non-y terms on the right side. So let's try to see if there's any guys that are out of place. Well, to me, it looks like the b is out of place. He's on the wrong side. He doesn't have a y. He should be on the no y side. And then the cy has a y, so he should be on the other side. So we're going to move both of those, b and cy. So we'll subtract cy from both sides. And then the negative b, the opposite of subtraction, is addition. So we will add b to both sides. These b's will go away. And these cy's will go away. And we'll be left with something like this. ay minus cy is equal to b minus 2. You could write negative 2 plus b, but remember, we really don't like leading negatives. Why don't we write b minus 2? Next, what we're going to do is we are going to pull out a common factor of the desired variable. It doesn't have to be a GCF. I mean, on the left side here, all we have in common is y, but let's say in common we had 3y. You don't need to pull out the 3 as well. You could just pull out the y. Kind of depends on the problem, but I usually just pull out the common factor and then worry about the rest later. So let's pull out a common factor of y, not necessarily a GCF, just what we want to get by itself. And we get y times a minus c is equal to b minus 2. All of a sudden, this is looking a lot more approachable. So the a minus c is being multiplied to the y, so we will divide both sides by a minus c. These a minus c's on the left here go away, that's great. And we get y equals b minus 2 over a minus c. That would probably be the answer. There's no real way to write that any neater, because remember how I was talking about, guys, there needs to be like one term on the bottom for splitting to potentially be a good idea. And notice how there's two terms, a and negative c. So probably just going to leave this as is. Okay, example 6. Once again, we see this very important phrase in terms of. And the letter that comes before it is W. So our strategy is we're going to try to get W by itself. So you'll notice here that, like a previous problem, the desired variable is in a denominator. However, unlike the previous problem where there was just one fraction, now we have like 4 separate fractions. This is going to be way too much manipulation to try to get this fraction and then by itself and then multiply by W, combine all those fractions on the right. It is going to be way too much work. So we should really use clearing denominators, which is a strategy I went over in one of my prior videos. I believe it's in Ottocento number 14. Basically, what you do is you just multiply the entire equation by the least common denominator. W, X, Y, and Z all have nothing in common, so the LCD is just all those multiplied together. W times X times Y times Z. So we're going to take this equation, we're going to multiply both sides by W, X, Y, Z. On the left side, the W's cancel, and we get 5X, Y, Z. And on the right side, each term in the denominator goes away, it cancels out, so the x's cancel and we get 5wyz. Then the y's cancel, we get 5wxz, and then the z's cancel and we get 5wxy. Now the next thing I'm noticing about this equation is that every single term has a 5. That's kind of pointless. We could take care of this at the end, but we might as well do it now. So what we're going to do is we're going to divide both sides of the equation, every single term, by 5. So basically all those 5s will just go away. And now this looks very similar to one of the prior examples. What we're going to do is we're going to get all the W terms to one side and factor. Very fortunately, all of the W terms are already on the same side. They're all on the right side. So we can just go straight to factoring. So we're going to pull out a common factor of W, and we get XYZ is equal to W times the quantity YZ plus XZ plus XY. We're in the home stretch now. That W is just being multiplied by something. Opposite of multiplication is division. So we're going to divide both sides by that big mess. The guys on the right go away. And we are left with W is equal to XYZ over YZ plus XZ plus XY. And that would almost certainly be how the College Board would write it in the answer choices. So here, clearing denominators was incredibly helpful to solving the question faster. So for example 7, we're going to do the exact same problem, just instead of isolating W, we're going to instead isolate Z. So we're going to get Z by itself. And if it's all right, I'm going to just kind of skip the first couple steps of work because those are largely the same. So like the clearing denominators and then the dividing by 5. I'm just going to skip past that. We just went over that. So the same couple steps are the same at the beginning. But notice how it's a little bit different. The Z terms are not all on the same side of the equation. So you could go either way, but for me personally, I'm going to try to get them over to the left. So those two orange terms, I'm going to move those to the left side by subtraction. So I'm going to subtract WYZ from both sides, and then I'll also subtract WXZ from both sides. And that will look something like this. Now that we have all the Z's on the same side, we can take out a common factor of Z, and we get Z times the quantity XY minus WY minus WX is equal to WXY. We are once again in the home stretch. That big mess is being multiplied by the Z's. The opposite of multiplication is division, so we're going to divide both sides by that thing. These guys go away, and we get a final answer of Z is equal to WXY over XY minus WY minus WX. And that would almost certainly be the final answer in a College Board answer choice. Okay, example 8. We'll now go over a couple type of problems with some radicals and maybe some more fractions, we'll see. We once again see this key phrase in terms of. We need to get D by itself because that comes right before that phrase. Now I notice that the D is in a fraction, and then it's also under a square root. So that square root is covering the entire fraction. So if you think about like PEMDAS, a root is kind of like an exponent. So we need to do that first before we tackle the fraction because the fraction is kind of like a group. Again, I don't really think about it too much. You kind of just gain the muscle memory the more you practice. So the opposite of a square root is squaring. So we're going to square both sides. And then this square root and this square on the right will both kind of undo each other. And we will be left with a squared equals 3bc over d. Now, this is very similar to problems we tackled before. I don't want the d in the denominator, so how about we multiply both sides by d? The d's on the right go away, and I get a squared d is equal to 3bc. And now the a squared is multiplying the d. The opposite of multiplication is division. So we're going to divide both sides by a squared. And we should get d equals 3bc over a squared. And that would very likely be the final answer. Okay, example 9. So once again, we see this key phrase in terms of, and the letter that comes before it is k. So we need to get k by itself. So for this one, I got the k minus 4, that's a group. I've got an exponent and I got multiplication. So reverse PEMDAS, we got to do multiplication before exponent. See how m, if we work our way from the bottom up, m comes before e, multiplication comes before exponent. So when we're moving things, we do it backwards. So the m is being multiplied, we're gonna divide both sides by m. The opposite of multiplication is division. These m's will go away, and we'll be left with j over m is equal to the quantity k minus 4 squared. Now, before we continue, I want to do a quick aside. So hopefully a lot of you guys know this, but if you have an equation with a square in it, let's say x squared equals 49, and I take the square root of both sides, we need to introduce a plus or minus symbol. And for the sake of convenience, you can put it on either side, but for the sake of convenience, we typically put it on the side opposite where the square is. So the square root of 49 is 7, but we wouldn't write x equals 7. We would write x equals plus or minus 7. And the answers would really be 7 and negative 7. The reason we do this is because 7 times 7 is 49, and also negative 7 times negative 7 is 49. So just make sure you don't forget to put that plus or minus symbol on the side opposite the square. Okay, so here I got a square, and we're going to take the square root of both sides. The square and the square root, they kind of cancel out, so to speak. But you'll notice I put a plus or minus on that other side. So plus or minus the square root of j over m is equal to k minus 4. Now, to make this easier, we can split this into two equations, one with a positive root j over m and one with a negative root j over m. And solving them is the same. For both of these, we're just going to add 4 to both sides. And we get these two results, 4 plus root j over m and 4 minus root j over m. Sometimes, so either of these would be fine, only one of them would be listed as an answer. I just wouldn't, the reason I went through this was I don't want you to get confused if College Board puts 4 minus root j over m, and then you go, where'd that come from? You know, it's like I want you to understand where both choices come from, just in case they ask you that other version of the choice. Sometimes in the question, they'll maybe tell you, oh, the constants are positive, blah, 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 and then you don't have to worry about the negative radical variant, but I don't know, I would just play it safe and put that plus or minus every time. Okay, lastly, we got example 10. Once again, we have this key phrase in terms of, and we need to get g by itself. Okay, first things first, that bg plus 3 is like a group, so we want to tackle that last, parentheses, tackle last. But multiplication we'll do before that a on the outside. So the opposite of multiplication is division. We'll divide both sides by a. We get c over a equals bg plus 3. Now we'll do addition and subtraction before we do the multiplication, so the 3. So we're going to take away 3 from both sides. And we get c over a minus 3 is equal to bg. Okay, next we got to take care of that b. It's getting multiplied, so we're going to divide both sides by b. Now, if I write it like this is like really nauseating to look at. It's very tricky. It's like, what the heck does this mean? Well, so I kind of suggest you don't write it like this, because of that fraction in the middle. Well, it makes it like a complex fraction, which could be hard to look at, especially if you only got like 2 minutes for a test question, right? So, what I suggest you do is you think about division, at least in this one, as multiplying by the reciprocal. So the reciprocal of b is 1 over b. So another way to write it, which will look neater, hopefully, to your eye, is we multiply both sides by 1 over b. That's the reciprocal of b. That's the same thing as dividing by b. That, to me, is much cleaner to look at. I can see that the b's will go away, and then I can see that the 1 over b on the left will go to the denominator of the b on the bottom will go to the denominator of each of those things. So we get c over a b minus 3 over b is equal to g. And that looks really good, but once again, you never know. Maybe they'll take it one step further and combine the fractions. So why don't we go over that for this one, just for the sake of being thorough. So we are going to, the common denominator is ab, that's the LCD. So we're going to multiply that 3 over b term by a over a. And he will transform into, instead of 3 over b, he is now 3a over ab. We now have a common denominator, so we can smush the fractions together. And we get g is equal to c minus 3a over ab. And really, either of those choices is fine. Just like we've been talking about, sometimes there's more than one good way to write it. And it kind of depends on what shows up in the choices of the question you're doing. So just be mindful. Okay, lastly, guys, these questions are incredibly hard, and you probably need to do dozens and dozens and dozens and dozens and dozens and dozens of them to get better at them. So I'm going to try to give you some more places you can go to practice more beyond just my own worksheet. So if you go to Delta Math and make a teacher account, you don't have to be a teacher. Anyone can make a teacher account. And if you go to the search bar and type in literal equations, there's this unit. It's like 5 skills in Delta Math. These are great. It's like procedurally generated literal equations. You can just do, as many of them as your heart desires. That would be a good place to start, I feel like. And on this page, I have some URLs with some more worksheets. I can copy paste these just if someone comments asking. I just don't really like putting this stuff in the description. It gets really cluttered. So just ask me. Again, you can just type this in off the screen too. Those little symbols in between the words are just underscores. Okay, it's time for the final review. Remember to download the free final review worksheet using the link in the description. Try to complete the worksheet yourself before watching the rest of the video. And I highly encourage you to ask relevant questions about this topic in the comments section. Let's jump to the whiteboard for the final review. Okay, question 1. So I see this really key phrase here, in terms of, and the thing that comes right before that is r. That's what I want to get by itself. R shows up in right here in the equation. So we're going to think, what are we going to do to get him by himself? Well, I've got this 25 and this 3D. Well, I have to move the 3D first because remember that reverse PEMDAS addition subtraction we take care of first. So I'm going to subtract 3D from both sides. I'm going to really neatly show my work, not just for the sake of the video. This is how I would actually do it on the exam. 3D minus 3D goes away. We get a plus 8 minus 3D equals 25r. And now 25 times r, the opposite of multiplication, is division. So we're going to divide both sides by 25. And we should get something like this. R equals a plus 8 minus 3d over 25. We could split this fraction up, but before we do that, before we even bother doing that, why don't we see if that's one of the choices? It looks like that is choice A, so we don't need to go any further. We can stop there. Okay, question 2. Once again, I see this phrase in terms of. The thing that comes before it is what we want to get by itself. That is B. All right, so what I'm gonna do is the parentheses is a group, so I'm gonna take care of that last. Let's move this 4 first. He's being multiplied, and the opposite of multiplication is division. So I get 3a over 4. This guy goes away. Equals b plus c. And now I just got to move the c that's on that side. So I'm going to subtract c from both sides. C minus c is 0, so this guy goes away. And we should get something like this. 3a over 4 minus c is equal to b. And at this point, we might have to combine the fractions, like put them as one fraction. But like we did in the last one, let's check to see if that's one of the answer choices. Then we don't need to waste any more time, right? So it kind of looks like this is choice C. So we're all good. We don't need to go any further. Okay, question 3. So I see this phrase here in terms of, right before that comes degrees Fahrenheit. So it seems like I want to get F by itself. And if you look at the choices, we can just kind of see that. That might be an easier way to make sense of that. Anyway, so the letter we want to get by itself is right there. Really quick way to handle this. We're going to move this fraction first because he's outside the group, outside the parentheses. Really quick way to get rid of a fraction is to multiply both sides by the reciprocal. So instead of 5/9, I'm going to multiply both sides by 9/5. And lo and behold, 5/9 times 9/5 is just 1, so those go away. And we get 9/5 c is equal to f minus 32. The only thing we have on the side with the f in it is that minus 32. The opposite of subtraction is addition, so we're going to add 32 to both sides. These guys here go away. Negative 32 plus 32 is 0. And we should get something like 9/5 c plus 32 is equal to f. And that is looking a lot like choice D. Okay, question 4. So what we're going to do is, it says in terms of, we need to get the 3q plus 7 by itself, which is over here. Now he is in a group, and we need to isolate that group. That's our first plan of attack. We're not going to clear denominators. It's only one fraction. It's not going to help that much. We got to get this 5 out here, though, so we're going to add 5 to both sides. This guy will go away. And we get 2b plus 5 equals 11 plus 6g over 3q plus 7. Now what we're going to do is we're going to get this guy out of here. We don't normally move the desired quantity to the other side, but we really don't want it in the denominator of a fraction. So nevertheless, we're going to do it. We're going to multiply both sides by 3q plus 7. Opposite of division is multiplication. And these guys will go away. And we get 3q plus 7 times 2b plus 5 equals 11 plus 6g. And now we're going to divide both sides by 2b plus 5. Opposite of multiplication is division. These guys will go away. And we should get 3q plus 7 is equal to 11 plus 6g over 2b plus 5. There's more than one term in the denominator, so it wouldn't really make sense to try to split this fraction. You can't do it in a nice way. Either way, it doesn't matter. It already looks like what we wrote is choice B, so we're done. Okay, question 5. I got two fractions equal to each other. Probably the easiest thing to do is to cross multiply. So we set the cross products equal to each other, the diagonals, the product of the diagonals. So 2 times 5c, well, 9 times ab, that's 9ab. And then 2 times 5c, that's 10c. And now I want to get b by itself. And you'll notice that is being multiplied by 9a. So we'll do the opposite of multiplication, which is division. You can do this all in one go. Divide both sides by 9a. These guys will go away. And we will be left with B equals 10C over 9A. And that is looking like choice B. Just don't forget, guys, another problem like this, you might have to simplify further. C and A, they don't have anything in common, and then 10/9 is a simplified fraction. So we're all good. Okay, question 6. These denominators have, first of all, there's 4 fractions, so we got to clear the denominators. These denominators have nothing in common, so the LCD is just all those letters, A, B, C, D. So we're going to multiply both sides of this entire equation by A, B, C, D. And we get the A's cancel in the first term. We get B, C, D plus the B's cancel, A, C, D. Now the C's cancel, A, B, D. Now the D's cancel, A, B, C. So now we want to get A by itself. So notice how this term, and this term all have an A in it. So we need to get them all to one side so we can factor. So since 2 of them are already on the same side, why don't I move this guy over here? So what I'll do is the opposite of addition is subtraction. So we'll subtract ACD from both sides. And this guy will go away. And we get BCD is equal to ABD plus ABC minus ACD. And now they all have a common factor of A, and we can factor that out. So BCD equals A times the quantity BD plus BC minus CD. And now we're in the home stretch. The A is getting multiplied by this big mess, so we're just going to divide by that big mess on both sides, BD plus BC minus CD. And these guys will go away. And we will be left with A is equal to BCD over BD plus BC minus CD. And hopefully there's nothing else we need to do to that. Let's look at the choices. That is looking a lot like answer choice D, which is the answer. Okay, question 7. Very similar to the last one, the least common denominator is just A, B, C, D once again, just a coincidence. So we're going to multiply both sides of this equation by A, B, C, D so that we can clear those denominators. So the A's cancel, and we get 8 BCD minus the B's cancel minus 8 ACD minus the C's cancel 8 ABD equals 8 ABC. So you can do this at the end, but I think it's just easier now. Everything has an 8 in it, so I'm just going to divide both sides by 8. Just to get rid of those. So I've got BCD minus ACD minus ABD is equal to ABC. And now we want to get B by itself, so let's search for all the B's. So B, got a B there, and we got a B there. Okay, so I suppose it's personal preference, but I would rather move this guy over here because there's more B's over there. And why don't I first get this guy over to the other side? Or we'll do it in one go. So I'll add ACD to both sides, and then I'll subtract ABC from both sides. So this will go away, and this will go away. And we will be left with BCD minus ABD minus ABC is equal to ACD. Now we're going to pull out a common factor. So of B, CD minus AD minus AC equals ACD. And then we're going to divide both sides. I'm running out of space here, guys. It's looking like ACD over that big mess. CD minus AD minus AC, which is choice A. Okay, question 8. This one is probably the hardest one on the entire worksheet. So we want to get k by itself. That's here. And we're going to, this is like a big group. We'll worry about that group later. But first, we got to get whatever's with the group out of there. So we got to get that I out of there. So we're going to divide both sides by I. Opposite of multiplication is division. These guys go away. And we get h over I is equal to the square root of 3 minus j squared over k squared. To get rid of a square root, the opposite operation is squaring. So we're going to square both sides. And because this h over I, everything's like one term, I can use distributive law of exponents to write that as h squared over I squared. That's probably going to make the rest of the problem easier, so why don't we keep it like that? And then this square root and this square cancel, and we get 3 minus j squared over k squared. So now I suppose it's personal preference, but notice how I have two fractions, and I can't cross multiply because I have that third term, so I really have like 3 fractions in a way. This is probably going to be way easier if we just clear denominators. We got I squared and we got k squared. They have nothing in common, so the LCD is literally just I squared k squared. So we're going to multiply the whole thing by I squared k squared. And in the first term, the I squareds cancel, and I get h squared k squared. And then I get 3 times I squared k squared. And then the k squareds cancel on the last one, and I get I squared j squared. And once again, now we can do like what we've been doing this whole time. So we're going to get k by itself. So I see a k here, and I see a k here. So we should probably get those guys to the same side. So I'm going to subtract 3i squared k squared from both sides. Why don't I move him over there? And this guy will go away. And we get h squared k squared minus 3i squared k squared is equal to negative I squared j squared. Okay, and I'm really not going to want that negative there if I start taking square roots and stuff especially. So how about this? I'm going to multiply the whole thing by -1. This is the negative I'm talking about. So remember, I'll go down here. That would give us positive I squared j squared on the right. And then remember, we talked about differences. When you multiply by a negative, the difference just gets switched around. So 3i squared k squared minus h squared k squared. And this looks really good all of a sudden. Okay, so now we want to get k by itself. And we're going to plot a common factor, not just of k squared, because they both have k squared. So I'm going to pull out a k squared, and I am left with 3i squared minus h squared. And then we will divide both sides by that. So we get k squared is equal to I squared j squared over 3i squared minus h squared. And now to get rid of this square right here, we're going to take the square root of both sides. We don't really need to worry about anything being negative or something when we take the square root as much, because it said at the beginning of the problem, positive variables. All right. So I'm going to take the square root of both sides. And that will look like this: square root I squared j squared over 3i squared minus h squared. And now that would be great if that looks like one of my choices. However, if you come up here, the one that looks closest to that is B, and there's no squareds there, so that can't be right, so I must have to keep going. Unfortunately, with multiple choice tests, it's not like on the AP exams where you can write down the answer. I have to make it look like the way the College Board wrote it. So what I'm going to do is I'm going to use properties of radicals, and I'm going to take the square root of I squared j squared, which is just the square root of I squared is I, and the square root of j squared is just j. And then that radical will just be over the denominator. Now let's go and see if there's a choice that looks like that. 1 second. And that is looking a lot like answer choice C. Okay, question 9. We want to get that s by himself. He's in a fraction bar, he's in a group, but he's in the denominator, and we really don't want him in the denominator. So we're going to move that guy to the other side. The opposite of division is multiplication. So we'll multiply both sides by the quantity s plus 4. And these guys will go away. And that will look something like this. S plus 4 times the quantity r minus 5 is equal to 3. Now what we can do is if we expand this guy, if we FOIL, it's just not going to look any nicer. We're going to have s's all over the place, and we don't want that. We don't want a factor. So how about we get this guy over to the right side? And to do that, we're going to divide both sides by r minus 5. So this guy will go away, and we get s plus 4 equals 3 over r minus 5. And now we're just going to move that 4 just like we normally would. We're going to subtract 4 from both sides. And this guy goes away. And we get s is equal to 3 over r minus 5 minus 4. And that is great. That could totally be the answer. As a matter of fact, I think question 1 or 2 was kind of like that, right? However, if you look at these choices, you will notice all of the fractions are combined. Oh, so that's how they get us. We need to find a way to combine these fractions. Well, if you think about it, this is really like 4 over 1. And the LCD is going to be, the least common denominator is just r minus 5, right? 1 is just a nothing burger, doesn't do anything. So what we're going to do is to turn this guy into an r minus 5 denominator is we're going to multiply the top and the bottom by the quantity r minus 5. So we're not even really doing algebra operations. We are, but it's more simplifying. We've already got the s isolated, right? So I've got s equals 3 over r minus 5 minus, I'll worry about the minus later. Keep that minus there. 4 times r minus 5. 4r minus 20. 1 times r minus 5 is just r minus 5. Okay, so now I got a common denominator, so now I just got to combine it. But you got to be really careful when you subtract rational expressions, guys. This minus sign here gets distributed to the whole thing. So it's really going to look like this. It's going to be like s equals 3 minus 4r, and then lots of people write minus 20, but it's really negative times negative 20 plus 20 over r minus 5. And if you clean that up further, you could just combine the like terms. Negative 4r, and then 3 plus 20 is 23. So the answer should look something like that. Just be really careful when you're distributing a negative sign to a numerator. You got to do it to every term in that numerator. Let's see if that is one of the choices. It is looking like that is choice B. The only difference is, instead of writing negative 4r plus 23, they wrote 23 minus 4r, which is equivalent. That's called the commutative property of addition. Okay, question 10. Little typo, guys. All these equations are supposed to say r equals. It should look correct on the worksheet you downloaded. Okay, so they want us to get the radius by itself, which is right here. So how about before we do anything, we get the fraction out of there, the 4/3. Remember we talked about we can multiply both sides by the reciprocal, so that would be 3/4. So this, and again, if it's more clear to you, you could write this as like v over 1. So these guys, the 4/3 times 3/4, that's just 1. And we get 3 times v, which is just 3v, over 4 times 1, which is just 4, equals pi r cubed. So now we got a coefficient, and we got an exponent. So don't forget PEMDAS. But we're doing it backwards. So we're going to do multiplication and division before we do exponent. So we're going to move the pi. We're going to divide both sides by pi. You can write it like this when there's a fraction, so that's more clear to you that it goes in the bottom. And we get 3v over pi times 4, but we should just write that as 4 pi. And now to get rid of a square, we take the square root, but to get rid of a cube, we take the cube root. So I'm going to take the cube root of both sides. this cube and this cube root should cancel out. I'm going to get r is equal to the cube root of 3v over 4 pi. And that is choice C, which is the answer. Okay, everybody, thank you so much for watching until the very end of my video. I really do appreciate it. Comment below your thoughts on the video and worksheet. Did you find them helpful? Be sure to like the video and subscribe for more digital SAT math content. And if you need tutoring, my website is linked in the description. I tutor SAT math and all math subjects from about 7th grade to AP/early college level. Thanks for stopping by, and good luck studying.